All right, so we were talking last week about sets of real numbers, right? So quick review. This is kind of the Venn diagram that describes it all. Did I show you that? Okay, so we saw the Venn diagram, correct? That all made sense. Here's another way we could describe the same relationships between sets and subsets. Right, we've got this set of real numbers that includes all the numbers you've ever used. We could split that into two subsets, the set of irrational numbers and the set of rational numbers. What's the definition of a rational number? The really simplest definition? Good. Numbers that can be written as fractions, right? Irrational numbers would be all the others. The rational numbers, we could split that up into the subset of integers and then all the rest of them, the non-integers, right? The set of integers we could break up into its subsets of the set of whole numbers which it contains, and then all the rest, which would be the negative integers, right? Those are the numbers that are not contained in the set of whole numbers. And then the set of whole numbers contains the set of natural numbers and zero, right? There's one other element that's not contained in the set of natural numbers that is a whole number. So give me thumbs on that. Does that all make sense? Okay, good, good. All right, so let's just practice a little bit. List all the elements of the set that are also elements of the set of integers. Okay, so we'll just go thumbs on this. Vote with your thumbs. 5. Good. 5 works, doesn't it? 0. Good. Square root of 3. Doesn't work. Thumbs down. Square root of 64. Yes, thumbs up because square root of 64 simplifies to 8. 3/4. No. It's negative 130. Yeah, okay, so we're good. We can fly through this stuff. We're good with all this. Okay, so quick review. Here's two different ways of saying the same thing, right? The written in green here, I've got this set with how many elements? Show me with your fingers. How many elements are in that set? 2. Good. 1 and 2. That's in roster form or set notation. We could do the same thing here in the orange. In the orange, we could rewrite this using set builder notation, which seems like a little bit of overkill in a way, right? Because it's a pretty small set. But this says the same thing. Now, how would I say this? Set of all x such that, okay? Does it make sense that those are the same sets? Give me thumbs on that. Okay? Any questions? Okay. A set that contains no elements, we call that the empty set if there's nothing in it. Or sometimes people call it a null set or the null set. We can symbolize it in a couple ways. We could use set notation. So we've got our set brackets, but there's just nothing inside. There's no elements. Or we can write it even more briefly as a circle with a slash through it. That's our symbol for the empty set. Here's an example of the empty set. How about this one? The set of all x such that x is a month with 32 days. Which months have 32 days? None of them, right? So that is the empty set. There are no elements in that set. So we could write it either way. Okay, what about this guy here? What is that? Is that, I'll say this a little differently. Let me ask you this. Is that the empty set? Did we talk about this last week? Oh, we did. Okay, I'm repeating myself. Never mind, we did that one. Okay, did we do this? Element of? Okay, so and we did that, right? Did we do the blue and the green? Okay, that's where we left off. Okay, good. All right, now I got it. So this is our symbol for is an element of. So how about the blue set? List the elements in the set described. The set of all x such that x is a natural number less than 1. You tell me about that. Empty set, yeah. There aren't any, are there? Okay, good. So that's the empty set. What's another way of writing that? Good. Circle with a slash. Okay, how about the green one? List the elements in this set. The set of all x such that x is an integer less than or equal to 1. Describe that set. What's that going to do? If I wanted to write that using set notation or roster form, well, first of all, how many elements are in that set? Infinite. So I can't write them all. So I've got to somehow just establish a pattern then, right? What's my pattern? What do you think? Yes, sir. Okay, good. I'm going to need an ellipsis, aren't I? I'm going to start with, at the upper end, I always want to write my sets in order, ascending order, right? So the biggest element would go on the far right. That's 1, okay? Then we would just work our way down. We know that we're just going to decrease by 1, but I don't want to write forever, so I'm going to end it up with an ellipsis that just tells us that pattern continues to the left, okay? Give me thumbs. We good on that? Okay. New symbol. Now this is different than is an element of. Is an element of, that's the symbol we would use when we're talking about discrete elements, so pieces of sets. This new symbol is contained in, can also be thought of as saying is a subset of. Okay, they mean the same thing. So this is the one we use when we're talking about sets. So for example, here's how we abbreviate in our textbook. These are the capital letters that we use to represent our sets of real numbers, okay? So this stands for the set of natural numbers. That stands for the set of integers. So you guys, true or false here? The set of natural numbers is contained in the set of integers, which we could also think of as saying the set of natural numbers is a subset of the set of integers. True or false? Got to vote here. I want to see where we are. What do you think? Thumbs up or down, or sideways if you're just not sure what I'm talking about. Okay, so thumbs up. Good. It makes sense, doesn't it? The set of natural numbers is a subset of the set of integers, so it's completely contained in that set, so it's true. Okay. Determine whether each of the following numbers is rational or irrational. If it's rational, determine whether it's terminating or repeating. So we'll just go rational, irrational. Thumbs up, rational, thumbs down, irrational. A. Yeah, rational. B. B should be really obvious because what's our simplest definition of the set of rational numbers? Okay, well, it is a fraction, isn't it? So that's clearly rational. C. Okay, that's down for sure, right? Because we simplified it and we're still stuck with a radical. D. Good. Okay, now let's pause for a second. If we have rational numbers that we need to write as decimals, how could we determine if they're repeating or terminating? Real simple. What do I do? Type them in a calculator. Sure, that's our simple way of doing it. Just use a calculator. And we'd find, if we did that, that 33/9 is repeating, 3.6 repeating. And we could just simplify the fraction and get there that way too. But, practically speaking, we're just going to take advantage of technology on this. And then D is obviously 0.5, so that one terminates. Okay, what about E? Rational or irrational? Ooh, you got I thought I'd trick some people, but I didn't. Did we talk about that? So we did this too? Okay, so I think what I did, I'm trying to remember for you guys, I think I changed up the notes, changed this up so it'd be better in your notes. But we've already, so you guys got to stop me. If I'm repeating myself, I don't want to waste your time. Just say, Mr. Roy, what are you doing? We already did this stuff. Okay, how about that? Did we do that? Okay, last thing. We'll just zip through this. This is just kind of some practice like for the homework stuff, but most people are done with the homework anyway. 0. You guys give me thumbs on this. Rational? Yes. Irrational? No. Integer. Yes. Real number. They're all real numbers, aren't they? Whole number. Yes. Natural number. No. Got it. Okay. 22. What are the only groups that one's not going to be a part of? Irrational. That's it, right? Good. Okay, -5 halves. What are the groups that one would belong to? Rational and real. There you go. Good. Square root of 9. What's the only group or groups that one wouldn't belong to? Irrational. Good. Square root of 3. What does that belong to? And real. They're all real. Good. Okay. And then 2.11. What groups does that belong to? Real and rational. And that's it, right? It's not an integer. So if it's not an integer, it can't be any of the other subsets of integers. Good. Okay, so there's the rest of our discussion on number sets.